Hello and welcome to More Interesting Maths. I'm David Myers with UTC South Durham. True to the name of the channel, this is More Interesting Mathematics. I'm going to show you a few elements of mathematics that inspired me to go and study maths at university and also afterwards just for curiosity. This is maths for maths' sake, for you at home, your curiosity and your entertainment. Generic introduction clip over, now let's do some maths. Today's puzzle is actually one of my favourites. I used it a few years ago when researching mathematics and problem solving. I think it's a lot of fun mainly because it seems quite simple to begin with, and when you start with it you've got a pretty good idea where it's going. It's not too tricky to get to grips with, but as you get into it, it can get really frustrating. It can start to do your nutting because it never seems to work. I probably shouldn't say this, but it was a lot of fun to watch the people who took part in this puzzle getting really frustrated because they couldn't quite see how to get it. On the other hand, there was one genius kid who managed to solve it in about 30 seconds, which I thought was remarkable considering it took me about 20 minutes to figure it out for myself. So which category are you in? Are you going to be like me, who's getting really frustrated and taking about 20 minutes over it? Or are you going to be one of those people who can solve it in about 30 seconds? Time alone will tell. The name of the puzzle is called the potato problem, and it reads: you have an unlimited supply of £7 weights and an unlimited supply of £11 weights, and you've got one £5 potato. Can you put the potato on the scales with a load of weights in such a way that they balance? And I'm going to argue that that is not an easy one. But to give you a bit of a visual hint, we've got some cheap, rubbish, old school scales here. I'm sure we all saw them being drawn in classes back in school. We've got some rubbish scale here, and on it we've got one £5 potato. To begin with, that's it. And then over here somewhere we've got any number of £7 weights, and we've got any number of £11 weights. You can use as many as you want, but you only have the one potato. So you could put a 7 on here, a 7 on there, an 11 here, an 11 here, an 11 here. You can do it in whatever combination you want. But can you make the scales balance? And is there an easier way of doing it? Is there another way of doing it? Try it out for yourself. So, to begin with, one of the nice ways to look at it, or one of the things that I suspect most of you will have done, is draw yourself a nice little scale and put 5 on one of the sides, usually the left-hand side. For reasons I don't know, that's what people tend to prefer. What I like to do as well is try and keep a running tally of what I've got on the left and what I've got on the right. To begin with, we've just got the 5 on the left and 0 on the right. Seems simple enough. The first thing I tried to do when I solved this problem, naturally enough, was say, right, well, let's try and put, say, 7 on the left. Well, okay, now it's out of balance, but it's only out of balance by 2. So let's try putting another... Let's up this to 14, so we'll add another 7 in there. So we've got 7 and 7 over here. And then if we put 11 over here, we've got 14 and we've got 16. Perfect, we're doing quite well. But they still seem to be out of balance. I've got 16 over here on the left and 14 over there on the right. So we're out by 2. Well, what could we do with that? We could add, say, 7 over here. That will bring us up to 21. And over here on the left, we've still got the 16. So why don't we add 7 to this side? Because that'll bring us a wee bit closer. So let's add 7 to the 16 and see what happens. 16 plus 7, that gives us 23. And we're out by 2 again. Now, I got stuck in that loop for absolutely ages. And I suspect if you did pause the video and you've had to go at this for any length of time, you will have some random combination of 11s and 7s up here somewhere. And you'll probably have got to the point where it looks a bit like this and you've run out of places to go. You'll have chucked any number of pieces of paper in the bin, I've no doubt. One of the things that got very interesting about that was it was only at this point, about 18 minutes into trying it out for myself, that I realised one of the major issues.
as will some of you. And this is the art of balancing. This is one of the elements of mathematics that I love. Solving linear equations. This is actually a very hidden version of solving linear equations when you've got something on the left that you don't need and something on the right that you don't need. And the key element in this is that if you've got a 7 over here, it counterbalances the 7 over there. In short, if you've got a 7 on both sides or an 11 on both sides, you've added absolutely nothing to the problem. But that helps in a strange way, because this is the key element of this puzzle. When you realise that having a 7 on both sides counteract each other, you've actually taken one step forward in solving the problem. Realising that doing something is useless is actually quite helpful when it comes to solving mathematics. A lot of people tell me that mathematics is just about forming some algorithm or something like that. I don't think so. I've always thought it's an incredibly creative process, and I think a lot more people could do with enjoying that. When you realise that something doesn't work, you've actually moved one step closer to solving the problem. Let's have a look at this one over here. What we realise in the end is that actually we've still got the 5 on the left hand side, that's always got to be there, but now we've got this 7 on the right hand side. We've cancelled them all out, and only a 7 can survive on the right hand side. If I had a 7 on the left, then I've lost the game, because I cancel it out again. So I can only have 7s on one side and 11s on the other. Question is, does it matter which way round that is? So I remember interviewing about 100 students from year 7 right through to 6th form. So students that had only just started on the GCSE maths journey, right up to students who were partway into a further maths A level. And the kid that solved this within about 40 seconds at most was in year 7. Incredibly gifted lad, and he just loved puzzles. I don't know whether it was blind luck that saw him right through to the answer, or whether or not he just spotted it in an absolute moment of genius. Some other students, most of them in fact, eventually found the way to it and were really satisfied when they got it. Other students, after the interviews, were so frustrated, but really quite satisfied with the solution that they saw. And I will show you what it was that said genius student did. I don't think he even drew the scales. He sort of had the picture in his head already. And he simply said, well, if I've got loads of, say, 11s on the right-hand side, then I just need to start with 5 and add 7 until I get a multiple of 11. So 5 plus 7, that gives me 12, plus 7, that gives me 19, plus another 7, that gives me 26, plus another 7, that gives me 33. Perfect. That was it. He'd found the solution. 5 plus 4 lots of 7 is equal to 3 lots of 11, so I need 3 11s on the right hand side and 4 7s sat there with the 5. Oh, wait a minute, no, I could do it another way. What if I were to start with the 5 and add 11? Well, then I'd get 16, plus another 11, we would have 27. No, neither of those are a multiple of 7 yet. What if we add another 11, we'd get 38. No, what if we add another 11, then we'd get 49. Oh, perfect. So 5 plus 4 lots of 11, and that would give us 7 lots of 7. So I'd need 4 weights of 11 if I put it with the 5, and 7 lots of 7 on the right-hand side. Again, it was an absolutely genius move, and that, no word of a lie, is pretty much the working out that he showed me, and that was the conclusion that he sort of expressed. Fantastic efforts if you got that at home. If you got any other solutions, please do let me know. Try it out with different numbers, see what happens. You're looking at a very disguised form of lowest common multiple there, as well as solving linear equations. There's loads of beautiful maths that you can do with this. For now, I'm not too worried about that. I'm just setting you some weird and wonderful puzzles at home. If you've got any puzzles that you think are worth sharing or having a look at, please do let me know. I love the messages that I'm getting, as well as a few of the comments. So please do tell me how you're finding it, and if there's something else that you want me to look at, do let me know. And that is it for this video, ladies and gentlemen. Thank you so much for watching. If you think it helped you out with your maths revision at home, then please click subscribe to get notifications on future videos. Share it with a friend if you think it will help them as well.
There is a PayPal account, but please don't feel obligated to do that. 10 or 12 pence if you think that it's worth it for you at home and you liked the video and the content that I've put out. Failing that, thank you so much to Dr. Frost Maths for the slides, for UTC South Durham for inspiring these videos, and most importantly to you at home for watching. I'm David Myers. Take care.